Yeah, okay. Um, the topic tonight is Logical Volume Manager, LVM. And yeah, my name is Achmad Mardiansyah from GLC Networks Indonesia. These are our agenda. So we'll be just talking about introduction, review, yeah, as usual, review prerequisite knowledge. We talk about the traditional not, operating system, traditional file system. Okay, what's the drawback of this traditional file system? And then after that, to improve the traditional file system, which may be not suitable uh, um, in your requirements, and then we talk about the volume manager, right? Okay, let me prepare, and after that there will be a practice. Okay, hopefully everyone can. Yeah, I cannot give you a access here because in order to do the file system things, it has root access. So, but at least you have an idea about how it looks like. Okay. Yeah, so that's all. The agenda tonight. Okay, let's start about the GLC itself. We are GLC, Lintas Cakrawala, glcnetworks.com. That's our website. We're based in Bandung. Our areas are training and IT consulting. We are doing MicroTik networking stuff, Ubiquiti and other vendors. We are doing Linux and then programming. We also do Radius Manager, our own platform for managing user Radius. And then we have a regular event uh, like what we do now. Yeah, this is me. I'm Ahmad, and I'm based in Bandung, a Linux user, MicroTik user, whatever user. And yeah, what else? Yeah, we do MicroTik and other stuff. And if you have LinkedIn, I would like to connect with you guys. Okay. Yeah, this is our past experience. We basically do network support. We do network uh, integration with other stuff. We also do, uh, yeah, some stuff of like a programming, and then other stuff for like a software related stuff. Okay, so yeah, places in Africa, in Europe, in Asia. Never been to America. Maybe in the future, who knows? Yeah, so that's what we did so far. About the webinar itself, it's a place to share knowledge, share what we know, and then everybody is welcome to join the webinar as presenter. And I would like to say thank you for all of you guys. I can see some of you are from Indonesia, of course. Yes, I can see it here. One from Afghanistan. Oh, okay. Thank you. One from Pakistan, other from Pakistan. Yes, yes. Some are familiar here. Okay, from I think a person from Timor. Here from okay, Sofia, Bulgaria. Oh, okay, that's far. Well, thank you. Hope you enjoy the webinar. Is there anyone that I didn't mention? Uh, any countries that I didn't mention? Okay, except Indonesia. Okay, no. Okay, so let's get started. So prerequisites. So we assume you already know storage. What is storage? What is partitions? What is FHS? File hierarchy standard. What is file system? And then mounting system on Linux. Yeah. So this is the prerequisite before we go to the logical volume manager. Okay, let's discuss. So as we know, when we have a computer, there is a one component that must exist on every computer. that is hard disk. Okay, that's the place where you put your data. If your hard disk lost, and then you'll be very upset because everything's there. Okay, money is not important, but data is. Right. So this is the hard disk. Okay, storage or I mean storage can be anything. Okay, and one type of storage is hard disk. But why? Because the capacity is large, and then the price is cheaper. Is there any other hard disk alternative? Yes, yes. For storage, people use like SSD. Yeah, it's another kind of hard disk. It's not using disk, it's using flash. So there is no platter like this anymore on SSD because everything is based on the flash like your USB drive. So there is no moving part like what we have on hard disk. Okay, so this is hard disk. This is the motor. I mean, sorry, this is the head. Okay, and then here, there will be a spindle here, which is turning the platter uh, uh, um, to the moving the platter so that it can be read by the header. Okay, and then here's the connector, and then yeah, some jumpers, and then of course there is a power. Okay, inside the platter itself, here's the center, and then what we have here is the track. Okay, so one track is this. Okay, and track is stack because there will be some platter. Okay, so one hard disk can consist of several platters, and then if one platter is stuck from one to others, and then this will become a cylinder. Okay, so what we know is first is the track, and then several tracks is stack become cylinder, and then when we partition the track here, we call it sector. Okay, so yeah, we start from track, and then track become a cylinder become the sector. Okay, and then the head is reading the tracks. Okay, depends on the where the data is. Okay, okay. So far, hopefully you can hear. You can follow up the material so far. Yeah, so this is how the hard disk looks like. Okay, this is the physical um, properties of a physical hard disk. Okay, start from tracks again. Here's the rotation of the spindle. Track become a cylinder, and then you have sectors. Okay, as simple as that. Uh, so after that, after we have the hard disk, and then the next thing that we need to do is the partition. Okay, so because hard disk is big, and then we don't want to all the whole hard disk to put all of our data. Usually we do partitioning. Okay, so you can think is you can think as an analogy of a land. So you have a land here. Okay, you have a house. Okay, you don't want to put everything in one room, right? So you have a door here for entrance. Oops, yeah, for entrance, and then here's you have a guest room. Okay, maybe here's you have a living room. Here's you have a toilet. Okay, living room, and then here you have bedroom. Okay, yeah, so partition is as you can think in my opinion. I mean, if you have any better analogy, yeah, you can say you can suggest something here to make it better. But my analogy for this partitioning is like you're partitioning your house. Okay, so you have to design from the beginning. Okay, this is where I put my bedroom. This is my toilet. This is the kitchen, and so on and so forth. All right. So yeah, uh, yeah. As I said, the tracks become cylinder and then sectors. Okay. So we need to do a partitioning. Okay, partitioning in hard disk is not like our house, where our house consists of, this is our house, right? We have x-axis and then y-axis here. Okay, this is 0, 0.0. But in hard disk, it's only one dimension. Okay, so only one way from 0 to x, for example. Okay, so this is how the hard disk is partitioned. So this is called sector 0, and then here's the last sector. Okay, so hard disk is only one way, only one dimension. So you can do partitioning from, for example, sector 0 until sector 100. Okay, so up to here, and then you start from 101, sector 101, 101 until sector 200, for example. So this is how you partition a hard disk. Okay, so this is partition number 1, and this is partition number 2. Okay, so we always base our partition based on sector. Okay, correct. So this is an example of a new drive. Okay, after we partition a new drive, so again, when we do partitioning, we always start from outer cylinder. So this is the outer cylinder. Okay, so we always start from the outer cylinder. Okay, so for example, this and this and this. Okay, so all of them, this partition uh, is a C drive. Okay, so I assume you are using Windows. Okay, so start from here. Okay, this one is start. Okay, and this is the where it stops. Okay, so the first sector and then the last sector for the C drive. Okay, after that there will be a D drive here, for example. Okay, and then yeah, that's it. So we have two partition, C and D, and after that we do a format. After the format, and then yeah, it will becoming like this. Okay, so this is C, and then this is D. Okay, this is how it looks like. Okay, in hard disk structure. So this is a partition. So as you can see, it looks like a room, but yeah, in two dimensional looks like a room. With the shape of a circle. Yeah, but in the reality, when we see a hard disk, it's just a string of one-dimensional, uh, one-dimensional dimension, one-dimensional, not so space, because space has three dimension, x, y, and z. But this one is only one dimension, only front and back. Okay, so this is how you partition your drive. Okay, you can do partitioning with CLI, command line partition, um, or you can do you can use partition software with the GUI like this. Okay, so we have two disks, for example, here, and then the first disk you do partitioning of this, and this, and this. Okay, so but this is Windows. Yes, we also have the same concept with 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 Linux, where we do partition based on the sector. Wait, but when I do partitioning, I never input a sector number when I do partitioning. Yes, it's done automatically. But again, when we do partitioning, we are always based on the sectors. I got a question. Is there any feedback or attendance? Well, yes. At the end of the webinar, yes, there is attendance and also feedback. Yes. Of course, yeah. And so the step one, uh, yeah, I think this is a step one. So you do partitioning. Oh yeah, before you do partitioning, you need to inform the this label or how partitioning scheme you would like to put here, and then this is um, applied on this level. Okay, not on partition level, but on this. So you apply partition or this label here. That can be DOS or that can be GPT. I really suggest you to use this one. I don't recommend you to use DOS. Why? Because if you use DOS or MBR, yeah, the total size, yeah, of this partition table is up to 2 terabyte. Okay. Yes, it's big. I know. Still big. Yeah, if you never have any drive that larger than 2 terabytes, you can use that. Okay, that's fine. But the in the servers that I manage, the capacity is huge. Okay, up to 100 terabytes, 50 terabytes, and so on and so forth. Okay, so I prefer to use this GPT. So those partitioning table or MBR, sometimes we call it MBR. MBR is master boot record. Actually, it's called DOS partition table. Yeah, that contains MBR. That's what it means. Okay. Uh, yeah. So DOS was designed a long time ago in maybe in 1980s, and then at that time, when people think 2 terabyte, they never they never have any think that okay, oh, the data becomes 2 terabytes. Oh, okay, it's very large. Yeah, at that time it's very large because my first hard drive, when I learned computer for the first time in 1990s, early 1990s, was 80 80 megabyte. Can you imagine 80, oh sorry, only 80 megabyte hard disk. This is hard disk, okay, not RAM. Yeah, the RAM was 4 megabyte. Okay, so this is RAM and this is hard drive. Yeah, early 90s. So I have to do partitioning on that 80 megabytes. Yeah, so at that time, mine also never think, oh, okay, 2 terabyte, what kind of data you put there? But now terabyte, okay, is very normal. So yeah, this is the steps that you need to do. Okay, this partition, and after that, you need to think about the file system. Okay, so file system is you know this is the I took it from the Wikipedia. Sorry, I forgot to put the um, reference later. I will put the reference later. So you have a hardware, and then on top of the hardware, you have to install the operating system. This is the very basic software. So you have a hardware, and then you have all of them. Here is software. Oops. Some people call it. This is hardware, and this is software, and then this is the brainware. Okay. So with the software, you have an operating system and then you have an application. Yeah, so the operating system needs to be installed first, and after that, it's you and your application that you are working with, like Excel, Microsoft Word, whatever. Operating system can be anything, right? But many people just care about the application. I don't care whether you are using Mac or Linux or whatever. I just want to use Microsoft Office, for example. Yeah, so that kind of yeah thinking, uh, yeah, it's like what normal, uh, not normal, what most people are thinking as well, not like us as an engineer. So for us as an engineer, if we want to we want we are the one that manage the system, right? And then we know more details about what's going on in the software side. So software side consists of operating system and application. So again, the operating system, when we talk about operating system, it consists of files, right? So you play MP3, and that MP3 is files. The operating system must have a kernel. So that kernel must have a form, and then that form is stored on a file, right? You have whatever. What else? You have a movie, and those movie are in file format in MP4, and etc. etc. So all of them. So operating system consists of files, correct? Right. So therefore, we need to have a system that is able to um, manage those files, and then it's called file systems. It's a system that is used to manage files, either the operating system own files or the files from the applications. Okay, so that's what it means. A system that controls how data is stored or retrieved. So it's a part of operating system. Okay, it's designed based on storage like this file system, a tape operating system. Sorry, file system, CD-ROM, network file system, uh, many types. Okay, so so every time you need to store data or retrieve data from a storage or to storage, you need a file system. Okay, and there are lots of file system out there where um, it's available for you to use. For example, for Microsoft, they have DOS or FAT. This is very old, I mean, traditional file system. And now they move to NTFS. Okay. For Linux, you have many options: extended 2, extended 3, extended 4, and XFS. Okay. Yeah. For BSD or Solaris operating system, they have a UFS. This is a very traditional, not traditional. It's yeah, it's still being used up to date. It's very stable, and then it's a native operating system of BSD. Can be FreeBSD, OpenBSD, any BSD. It's UFS. On Solaris also use Unix file system UFS, and then now they have uh, zettabyte file system, which combine the file system and then the partitioning scheme. Okay. Okay, any questions so far? No? Yes, yes. DOS is not an FS. It's a, yeah, yeah. It's a, it's an OS. Yes, yes, correct. Thank you for Tihu, yeah. Yeah, so I put here Microsoft, yeah, DOS is this operating system is operating system, yes. And then the file system is called FAT. Yes, yes, true. Uh, yeah, sometimes people say it's a FAT. Okay, the technical name is FAT, file allocation table. But sometimes, yeah, people, which file system do you use? Just put the DOS operating system. Actually, what they are saying is a DOS. I mean, FAT operating system. Okay, right. So, okay, let's continue. Yeah. So after we put a file system here, the way we put the file system is by formatting the partition, right? And after that, after setting up a partition, we format everything there. All data is being wiped out, and then we have a file hierarchy standard on Linux. Okay, so on Linux, we have a structure of directory start from the root. So compared to Windows operating system, uh, Linux has FHS, file hierarchy standard, looks like an inverted tree. So this is tree, okay, so you have a tree here, and then this is you have root, okay. Root is located at the bottom, yeah, and then here's the tree. But in Unix operating system, root is on top, okay. It's a root directory, it's called slash. And then under the root directory, we have several directory as well, like bin, sbin, or lib, okay. This is for essential programs where you put your binary execution files here, and we have non-essential programs. Here are the directories, okay, and then you have a user, a kernel file system, and then other mount points, okay. Yeah, so these are some examples. So if you install a Linux file system, and then you will see why there are lots of directories here. What's the meaning of them? So here they are. Okay, so FHS is defines the directory structure and directory contents in Linux distribution, and then it's maintained by Linux Foundation. Yeah. Oh, I have a question here. What's the difference between HDD FAT and NTFS with SDD SDD? Well, first, HDD, sorry. So HDD versus SSD, right? Okay, so HDD is the traditional hard disk with spindle. Spindle means platter. Okay, so yeah, like a platter that is moving, doing rotations. If you want to retrieve your data, and SSD has no platter. Okay, that's the big difference between them. Okay, so that was the difference between HDD and SDD. It has no moving part on SDD. And then FAT and NTFS, yes, that one, the specification for FAT and NTFS is on Microsoft. They never opened the specification for FAT or NTFS. So um, I, I'm, I don't really have a detailed information about that. Right, thank you, Ucho. Yeah. Okay, so we have already know the FHS. So the good thing for FHS is that it will give us the consistent structure. Okay, it's like, where do you save your files? Oh, okay, I put my files in /home / something. Okay, so you just only remember this one. Okay, so where is the C drive? Where is the D drive? Okay, this is what you have if you are using Windows, right? C drive, yeah, or D drive, right? This one. Oh, with backslash, right? Sorry. C this one or C this one. Okay, so yeah, I use Linux in my daily basis, so I perhaps forgot what the Windows looks like. So I use last time I used Windows was a long time ago, maybe more than 10 years, maybe 15 years, in 2007. Yeah. So after that, all my laptops are based on Linux or a Mac. Okay, so yeah, that was file system, and then FHS, and then we have a traditional partitioning here. So same thing. This is a GUI for uh, how you do partitioning on Linux. Okay, so the step is yeah. Okay, so the step is do partitioning, and you do formatting. This is the phase where you put the file system, and after that you do mounting to FHS. Okay, But again, with traditional partitions, you're partitioning your drive based on the physical parameter that is sector. Okay, so you have sector number 0, and then sector number, for example, 2943, for example. I just made up the number. So partition number 1 will be from 0 to 501, okay, to sector 501. So the next partition is from partition 502 until 603, for example. Yeah. So everything is based on sector. What happens if one partition is full? Well, you have to move your data away and then reformat and then do partitioning again. Sorry for that. So that's why we came to an idea. What what about if we make the partitioning more dynamic? Yeah, so that's what we are doing today. Okay, so it brings us to the LVM, Logical Volume Manager. So here, so instead of partitioning the files, not partitioning the files, partitioning the hard disk. Sorry, my mind goes here and there. So instead of partitioning the hard disk, so the idea is to have an abstraction layer so that we can easily or on flexible way for managing our file system, right? So we have a physical volume here. It can be SDA, SDB, okay, SDC, okay. So everything goes into one volume group, okay. So it's like one big pool of hard disk. And then on top of the volume group, we have the LV, the logical volume. Okay, so this is the one that you consume. Okay, we consume. Okay, so this is what we consume, the logical volume. So here's the step, okay, the PV and then VG and then LV. Okay, after that you do the formatting of the file system. And then actually there is one thing here is mounting. Okay, so what's the benefit of LVM? First, the volume can consist of more than one disk. What is the biggest hard disk available on the market right now? 20 terabyte, right? 20 TB. Okay, so there is a requirement here from your customer. I want to make a drive, yeah, drive, C drive, F drive, whatever drive, okay. And then that partition has with with the size of 100 terabyte. How can you do that? There is no files. There is no hard drive that has a size of 100 terabyte up to now. So how can you achieve this 100 terabyte? Well, you can use LVM here. So this means you have 120 terabytes, another 20 terabytes, another 20 terabytes, and then you can join them. Okay, and then you can achieve 100 terabytes. As simple as that. Okay, so these two 20, 20, 20, 20, 20, okay, you combine them and then you will get 100 terabytes. Yeah, so that's the benefit number one. Also, with LVM, you can also do resize operation. You can increase or extend or reduce the 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 the, the, the file system. Yeah, so remember the one that we consume is this logical volume. Okay, so everything here is related to logical volume. Okay. Oh, okay. Maybe accept this. Yeah. So we can resize. So the one that we resize is the logical. We can redo replacement. Okay, so this, if this one is down, and then we can replace them. There is a snapshot of uh, LVM, the LV, and then we can add new volume up to 256 logical volume. Okay, so yeah. Oh, okay, let's do the practice. Yeah, so you guys, if you are interested, okay, while I'm preparing the lab, yeah, if you are interested, you can join our training here. The schedule is available on our website. And yeah, as I said, there will be a feedback. Okay, I'll share the feedback URL here. Feedback URLs there, and then if you want to know more, you can visit our website. Slide will be available on Slideshare. Okay, yeah, you can join it, and then recording will be available on YouTube. Okay, I will update the URL here. Okay, so or you just type GLC Networks on YouTube, and then yeah, you can find our channel. Okay, let's do the demo. I will share the whole screen. Okay, here it is. So I have, can anybody see my screen? Hello, can you confirm you can see my screen? Okay, great. Yeah, so this is my screen, and then I can use CFDisk to display all the disks I have. Okay, or I can use fdisk minus L, and then I can see here I have, so this is fdisk minus L. All right, here you can see the total disks I have on my system. Okay, so how many disks do I have? Okay, I can see it here. So I have SDB, so this is disk number 2, SDA, hard disk number 1, and then SDC. Okay, and then here this one has 200 mega, here's 12 gigabyte, and then 200 megabyte. And then with this, it consists of one sector. So okay, sector, the typical sector size is 512. Okay, and then the disk label, see, as I said, it's DOS. Okay, that's why I put that DOS. Okay, but this one is not, it's using GPT. Okay, that's what I said. Yeah, actually this should be FAT, right? File allocation table, but here is the disk label. Okay, this label for that. Yeah. Okay, so this is the disk identifier, and then after the disk, okay, you have a partition. This is the partition. So SDB consists of 2 partitions, and you can see the partition, the first partition here start from here up to here. Okay. The second partition start from here. So as you can see, the previous partition stop at 104.447, and then the new partition is one sector after that. Okay, again, this is the sector start and end. Okay, so you do partition, start, end, and then here's the total sector. And then if you convert into size, how many megabytes? It is 50 megabytes. Okay. All right. So if you want to use them, oh, maybe we can, SDB. Maybe we can start from beginning. M for help. Okay, as you can see, this is a new label. Okay, so these are the options for label, this label. So currently the hard disk is using GPT. As you can see, is the GPT, but we can change it. Okay, so we can use DOS, SGI, or GPT, or Sun partitioning table. Okay, so as I said, better use GPT. Okay, so I will put here a G. Okay, done. So this label now is GPT. And then if you want to print, and then we put here print partition table. Okay, and then there is no, so if we create a new label, it means that all the partition there is gone. Okay, and then don't forget to write that the changes that we did with W. Okay, it's done. And then we can do cat to check proc partition. Okay, and on SDB, oh, there are two, there's still two. Okay, never mind. We can do F this again, and then press P, press M. Okay, if you want to delete a partition, we can do D here. Delete partition. Oh, no partition is defined yet. Oh, okay. So yeah, that's because we create a new empty GPT. Okay, never mind. So it means that we need to create a partition. So press N. Okay, partition number 1. See, it says the first sector. Okay. Why we cannot use the sector number 0? Because those sectors is already allocated for other purpose, like MBR, or to put a Linux loader, to put the boot up loader, whatever. So the first sector we can use is 2048. Okay, so we just press enter, we agree. And then what about last sectors? So it means that we need to do calculations. Well, you can do that, but I choose the better way. So I just want to I want to create a partition with the size of 60 megabytes. So this is what I put. So I plus, and then 60, and then the units. So it's megabyte here. And then it will calculate it will search the N sector. Okay, so the first sector is here, and then here's the last sector of the disk. But I'm not using all of them, so I'm just using that. Okay, please find a sector that has 60 megabytes from the first sector. Okay, you want to move signature? Yes. Okay, and then press the partition. As you can see, here it is. So the first partition is this. So this is what I put, right? So it asks for the first sector, 2048. So it's similar to this. Okay, and then the last sector. The way I put last sector is by using 60 megabyte. So it's going to be like this, and it's similar to the end sector of this one. Right, the total sector that I have is 122,880 sectors. Okay, yeah, so that was the first sector. I mean the first partition. So let's add a next partition. So partition number 2. Yes, see. So the last partition was 124,927. So the next sector will be, yeah. So the next sector will be 28, yeah, 124, 928. So that's the next, the first sector for the next partition. Okay, so plus here, and then for the last sector, it asks again for the last sector. So this is how you define actually a partition. So by defining a sector, 60 megabytes, and then press P to display, and then yeah, so we already have two partitions, and don't forget to write the partitions, and then should be okay. Do we have to mount? Oh, okay, so that's why it's still mounted. Okay, unmount. That's why. That's why. F this P. Oh, it's failed. Ah, yeah, that's okay. Part group. Yeah. Oh, okay, never mind. Yeah, okay, so we already done. Okay, let's do our partitioning. So first is PV, as we mentioned here. Okay, so how do we say how do we display PV by PVS? So as you can see, there's already currently PV. PV is already there, but on SDB, it's nothing. There's no PV or physical volume for SDB. So we can add one. So PV create def SDB1. Okay. I think I already unwound the file system. Oops. Def. Wipe it. Yes. Okay, so it's done. So we can check LVS, PVS. Yeah, it's done. So SDB is already become a PV, and we need to assign to a volume group. So we can create VG create, for example. I think there is a name for that. Okay. Yeah. Yeah, VG create, we put a name, VG, for example, uh, food, for example, food, VG food, and then the member is dev/sdb1. Yeah, it's done. So we can display VGS. Okay, so we have VG food. Okay, do we have LV? Yes, LVS we have already here. It's done. Actually, the root and swap is only done by when you do installation. So we need to create one that is sitting on top of our current volume group, which is VG food. Okay. So let's create LV create LV. Let's say the name is LV burger. Oops, LV burger. So it's the name of food, right? And then the size is 10 megabyte from VG food. Okay. Oh, sorry. Minus n. Yes, create so LVS. Yeah, so it's done. So as you can see, here this is the volume group. The volume group is this one. here, right? So it's called VG food. And then on top of that VG food, we have LV burger. Okay, LV burger is the volume, logical volume. So this is the one that we consume, LV burger. Okay, and then it's from VG food. Okay, so that's how you read the information. So what we can do is we can do mkfs dot extended for example. So def vg food lv burger. Yes, it's done. As simple as that. And then we can do mounting. So we can prepare a directory for that. /mnt lv burger. Okay, so we do mounting /mnt. Oh, sorry. /dev /vg food lv burger to mnt lv burger. Oops. Yes, and then check the mount. Here it is. Here we have. Okay, so as simple as that. Can we resize? Yes, it's possible to resize. We can do like a manual resize. Okay, so here you can see df minus h. So this one has 10 Mbps size. Okay, so I want to increase to 20. Is it possible? Yes, yes. So we can do lv resize minus r to, for example, 20 megabytes. Okay, /mnt /dev vg food lv burger. Yes. Okay, so a simple test, as you can see. So the size is increased. Let's check df. Now it's 19. So before it's 10. Okay, so you can see the difference now with very, very simple steps, right? So before it was 10 and now becomes 19, like this. Okay, how to do that? We are doing resize, LV resize here. Okay, so yeah, I think that's all. Any questions? Any questions so far? Hello? Any questions? No? Okay, if no, and then I think it's time to finish the webinar. So hopefully you can enjoy the event today, and then yeah, get some insight related to LVM. So as you can see, LVM will make your life easier. Okay, if your partition is full, and then you can resize. Okay, and then you can also combine several hard disks into become a volume, for example. Right. Oh, okay, I have a question here. What if the hard disk one failed? How to remove it and rejoin the VG group? Okay, so for that one, you can we can set up a we can set up like a RAID, for example. Yeah, because here the things that I'm doing is only rely on one hard disk. Okay, so only SDB here. So what happens if FDB is gone and then all data is lost? Okay, so all data is lost. You can do things like a RAID. Okay, maybe we can discuss RAID in the future. Okay, called RAID. Okay, and then with the RAID, yeah, there is a RAID RAID 1, which is mirror. Okay, mirror means you have two hard drive, okay, with the same size. So if one is down and then the other still survive, and then you can just replace this one. Yes, you can combine with the RAID. Okay, or perhaps in the future you can just use ZFS. ZFS will be having another ZFS webinar in the future. So yeah, perhaps that might be um, interesting to know for this ZFS. Okay, so hopefully that could answer the questions. Yeah, okay, thank you. You're welcome. Right, guys, so we are finished today. Uh, Hopefully you can follow the, the materials, the topics, and then it's time to take a picture. Yeah, please open your cameras here, right? And then I'll take a picture from you. Hopefully you're looking good now. Great. So let me take a picture. 1, 2, 3. Oh, okay. Thumbs up. Thumbs up. Yes. 1, 2, and 3. Great. Okay, next page. 1, 2, and 3. Good. Right, so again, thank you very much for coming to the webinar. So hopefully you have an idea of how the LVM works, okay, which is very useful, especially if you are working as a Linux administrator that manage many Linux system. Anything else? No, so it's time to say goodbye, and then please, for those who are new or wants to make the webinar better or wants to submit topics for the next webinar, yeah, please submit something on the feedback here. Again, thank you very much for coming, and then see you in the next webinar. Okay, and have a nice day and goodbye.